So now I'll be looking at perimeters and areas of sectors and segments of circles. So what's a sector and a segment? So a sector is a section of a circle that is bounded by two radii and an arc. So when you have two radii like this and you have an arc, that section is referred to as a sector. What about a segment? A segment is just a part that is divided by a chord. So when you divide a circle by a chord, as you can see here, so those two parts are called segments. So the smaller part is called the minor segment, while the larger part is called the major segment. So let's look at how to calculate the perimeter of a sector now. So to calculate the perimeter of a sector, I'm first going to try to bring out how a sector looks like. So a sector looks something like this. So you have your two radii here and you have your arc here. As we discussed before, perimeter is just the same thing as finding the sum of all the edges. So the sum of here plus here is just going to be r plus r, and the sum of here is just going to be the length of the arc. And we have talked that the length of the arc is given by the formula theta over 360 times 2 pi r. So what will that give us? R plus r give us 2r. Then we have plus theta over 360 times 2 pi r. So that is why this is the formula for the perimeter of the sector. So we just add the two radii together, then we add it with the length of the arc. So what about the area of a sector? So the area of a sector is just trying to measure the space within a sector, and to do that, I'll start out by explaining the area of a circle. So let's assume I have a circle now. So what is the area of this circle? I know that the area of a circle is given as pi r squared. But what about if I take a section out of this circle and I want to calculate the area of this part over here? So now I can call this angle theta, and since I know that the full angle in a circle is 360 degrees, I can make this angle theta as a fraction of the full angle. So I can write the area of a sector to be equals to the fraction, which will be theta over 360 times pi r squared. And how do I know this is correct? So the way to test it is to assume that what will be the area of a full circle. So for a full circle now, I know that theta will be 360 degrees. So my area will just be what? 360 over 360 times pi r squared. And as you can see, 360 cancels out 360 and I just left it what? Pi r squared. So for a circle, the area is pi r squared. But when I'm calculating a sector, I just divide that angle obtained there, theta, by 360, if multiplied by pi r squared. So let's look at an example. So here we are told that an arc subtends an angle of 65 degrees at the center of a circle which is just 6 cm. Find the perimeter and area of the sector. So to get started, first thing I want us to do now is to sketch it out. So we have an arc, or let me draw the circle. So now we have an arc that subtends an angle of 65 degrees at the center. So this is the center of the circle. So we have an arc that subtends an angle of 65 degrees. So first, I'm told to find the perimeter and the area of the sector, and what I've been told that the radius is what? 6. So the first thing I want to do now is to find the perimeter. So know that for the perimeter, I've been told that the perimeter of the sector is given as what? 2r plus theta over 360 times 2 pi r. And what would that be? That would be equals to 2, and my radius here is 6, then plus my theta here is what? 65 over 360 times 2 times my pi I take as 3.142, and my radius in this case is what? Is 6. So 2 times 6 gives me 12, and when I punch this into my calculator, you get 6.81. And when you sum it together, what do you have? You have what? 18.81 centimeter. So the perimeter of this sector over here that is indicated with this red marker is what? 18.81 centimeter. So the second part now asks us to find the area. So we've said that the area of the sector is given as what? Theta over 360 times pi r squared. So that is pretty straightforward. So that becomes, what is my theta here? 65 over 360 times pi is 3.142, and my radius is 6, so I have 6 squared. That becomes 65 that is 3.142 times 36 over 360. And when you punch this into your calculator, you get your area to be equals to 20.423 centimeters squared. So what you should notice is that the unit of my perimeter is in length, so I have centimeter, and the units of my area are in length squared, so I have centimeter squared. So now let's talk about the perimeter of a segment. So how do we find the perimeter of a segment? So the way to go about it is, a segment, as we have discussed, is the section that is brought out or divided through the help of a chord. So when I have a chord, say AB, the two sections are called segments. So I have the major segment, the bigger part, and the minor segment, which is the smaller part. So let's assume I want to calculate the perimeter of this minor segment. So, and I'm going to bring that out. So what do I have? I'm going to have something of this sort. So how do I go about that? So the first thing I want to do is I have to calculate the length of this chord. Now in the previous video, I've discussed how to calculate the length of the chord, and secondly, I want to calculate the length of the arc. So when I calculate the length of the arc, I just add it to the length of the chord, and that gives me the perimeter of a segment. So let's use the next example to illustrate what I'm talking about. So here we are told that a chord AB subtends an angle of 120 degrees at the center of the circle, radius 7 cm. Calculate the perimeter of the minor segment. So as usual, the first thing we want to do is we want to sketch the problem out. So we have a circle, and we have a chord AB. So I have chord AB that subtends an angle of 120 degrees at the center of the circle. So the angle subtended there is what, 120 degrees. So I'm told to find, and the radius is 7. So I have 7 and 7 here. I'm told to calculate the perimeter of the minor segment. So since this is a chord, the minor segment is the portion that is indicated by this weight marker, this smaller section, and while the part up is the what, major segment. So now to find the perimeter, I know that I have to find the length of the chord, and I need to find the length of the arc and add it together. So I'll start by finding the length of the chord. So to find the length of the chord, if you recall, first thing we have to do is we have to bisect this angle over here, and when we do that, the angle here will be 60 and the angle also here will be 60. Now I can bring out this triangle, and I have something of this sort. So I have something like this, in which the radius here is 7 and the angle here is 16. So now I know that my sine theta or sine 60 is equal to opposite over my hypotenuse, which is 7. So my opposite is going to be equal to 7 sine 60, and that is equal to 7 times root 60 is sine 60 is root 3 over 2. Then 2, this gives me what? 3.5 root 3. So the length of this section is 3.5 root 3. So here is what, 3.5 root 3. But similarly, since these triangles are similar, so this place is also what, 3.5 root 3. So the length of the chord now, so the chord length will be equal to what, 3.5 root 3 times 2, and that gives me what, 7 root 3. And if I want to express that in decimal, that is going to be equal to 12.124 centimeter. Now the next thing I want to do now is to calculate the length of the arc, and I know that the formula for calculating the arc length is given by what, theta over 360 times 2 pi r. So that becomes what, my theta in this case is what, 120 over 360 times 2 times my pi I take as 3.142, and my radius is 7. When I punch this into my calculator, I get what, 14.66 centimeters. So that is the length of the arc. So now I can write out that the perimeter of the segment, now perimeter of segment will just be equals to the length of my chord, which is 12.124, plus the length of my arc, which is 14.66. And what does that give me? That gives me 26.79 centimeter. So the perimeter of the minor segment is 26.79 centimeter. So to recap, what we did was that we first tried to calculate the length of the chord, and when we did that, then we tried to calculate the length of the arc, and after we accomplished that, then we now added two of them together. So let's look at how to calculate the area of a segment. So now let's assume we have a segment as we've seen here, and we're trying to calculate the area of this segment. So how do we go about it? So the first now to think about is try to think about, like, we have a center here. This is the center of the circle, and I draw a line over here. So now you can see I have the radius here. I have a sector, and to sketch it out so that you can see more clearly, I have the radius here, I have the radius here, and this is my chord AB, and this is the segment that I'm interested in, this place that I shaded. So as you can see, this figure here is a sector. So what can I do? I can try to find the area of the sector. So when I find the area of the sector, which is something like this, I can now minus the area of the triangle from it, this triangle that is on top. So when I minus the area of the triangle that is on top, what would I be left with? I'll just be left with the segment that is desired, this portion. So to find the area of a sector, we already know that that is equal to what? Theta over 360 times what? Pi half squared. Now we know that the area of a triangle now in terms of r and angle theta can be given as half times r times r times sine theta. If you don't know about this is also an alternative formula for calculating the area of a triangle, which is given as half AB sine t, half AB sine t. But since we are talking of r and r now, a and b are both r and t is theta. So when we solve this now, we have what? We can see that we have theta over 360 times pi r squared minus half r squared sine theta, and you can see that r squared is common to both of them. So you have r squared into big brackets, you have theta pi over 360, then minus sine theta over 2. So that is how we result in this formula. So to calculate the area of a segment, to make use of this formula, theta pi over 360 minus sine theta over 2, then times r squared. So let's look at an example. So we are told that a chord AB subtends an angle of 75 degrees at the center of the circle of radius 9. Calculate the area of the minor segment. So the first now to do is I want to sketch that out. So I have the circle and I have the chord. Let me indicate out another marker. AB subtends an angle of 75 degrees at the center. So if this is the center, I have an angle of 75 degrees over here, and I'm told to find the radius is 9. I'm told to calculate the area of the minor segment. So from our former derivation, so what I'm interested in is this segment over here. So I've written that what the area of segment is given as what? Is given as half squared into bracket theta pi over 360 minus sine theta over 2. So what does that become? That becomes 9 squared into bracket theta in this case here is what? 75, and pi is 3.142 over 360, then minus sine, my theta is 75 over 2. Now 9 squared gives me 14, 9 squared gives me 81 into bracket. When I punch it into my calculator, I have 0.6546, then minus, when I punch it in my calculator, I have 0.4830, and that gives me 81 times this minus this gives me 0.1716, and when I multiply by that by 81, I get 13.9 centimeters squared. So the area of this segment or this shaded region is 13.9 centimeters squared. So this pretty much sums up how to calculate the perimeter and area of both sectors and segments.